All right, so the first four, we're finding inverses. Okay. And that's when we switch our x's and y's. Okay, so our, f of x is like y equals. So when I do these, I just write, instead of f of x, I write y equals. Okay. And then we got to switch the x and the y. Okay. So we're going to change it to x equals 5y minus 15. Okay. And then we just solve for y. All right. So I want to get that y alone. So I'm going to add the 15 to both sides. And then I got to divide by 5. So that's all we got to do. We don't have to worry about any restrictions because there's no variable in the denominator. Okay, so this is okay if you want that. Okay, or some people split this up into two fractions. You could write it as 1/5 x plus 3. And if you want to write f inverse, you can. You don't have to. Okay, if you just leave it like that, that's fine. Nothing wrong with that. Okay. Any questions on that? First two are pretty easy. All right, number 2. Very similar to that one. Again, it's f of x. I'll write it as y equals. So we're going to change it to x equals 4y plus 1. Just swap the x and the y. Okay? So we're going to just subtract the 1 from both sides and divide by 4. Get y by itself. Okay, so this is okay. You left it like that. Or some people, and again, the book, if you're looking at a book answers, they would split it up into 1/4 x minus 1/4. But again, you don't have to. You can leave it as just that x minus 1/4. So the first two are pretty easy. Any questions? Okay, the next two are a little bit harder because you have, an x in the top and the bottom, so then you end up having a y in the top and the bottom. Okay, so we've got y equals 6x over x plus 2. And usually what happens is you guys get a little sloppy and you can't tell the difference between your x's and y's. Okay, so try to stay neat. So we're going to write x equals 6y over y plus 2. You got to interchange, swap them both. Those x's become y's. And the y becomes an x. Okay, so now we have that y in the denominator. I have to get it out of there. So I have to multiply to move it out of there. Okay? And remember, what you do to one side, you got to do the other. Okay? So these cancel and just leaves me that 6y on the right. And here you're going to distribute. So it's going to be xy plus 2x. All right, so I distributed that x times the y plus 2. Okay? So I have a y on each side. Right? I want to get the y by itself. So it doesn't matter if you take the xy on the left over to the 6y on the right, or take the 6y on the right over to the xy on the left. That doesn't matter. Since this x is here on the left, I'm going to take this xy over to the right, so that the y's are on the right. So I got 2x on the left and 6y minus xy on the right. Okay, so here's the spot where some of us get stuck. All right, you know we have to get y by itself, but you got 2y. Okay, so what you do here is you treat that y as a GCF, and you factor it out. You take the y out, and you just divide 6y by y and get 6, and negative xy by y and get negative x. So it looks like that. So that's the spot where some of us run into a little bit of trouble. And when you pull that y out, factor it out, that means y times 6 minus x. So to get that y by itself, I got to divide by that 6 minus x to get it to the other side and get it out of the right position. 6x, sorry. Okay, so then those 6 minus x's on the right cancel. And here's our answer then. Okay, now when you have a variable in the bottom on these, you have restrictions on the variables, a number that the x is not allowed to equal. Okay, and the number 6, if I put in for x, that would make it 6 minus 6 and give me a 0, which I'm not allowed to have. So you should write that restriction, x cannot equal 6, to finish that up. Questions on that one? So, 3 and 4 are similar. You're going to have multiple y's once you switch. So you want to get the y's together on one side and then factor that y out like it's a GCF. Okay? Questions? We all right? Okay, number 4. Again, instead of f of x, I just think of it as y equals. Okay, so we're going to swap it out. So x equals 2y minus 4 over 3y plus 6. Okay, we got that y in the denominator again. So we're going to move it out by multiplying both sides by 3y plus 6. So those will cancel. And then I'm going to distribute. So I got 3xy plus 6x equals 2y minus 4. Okay? So I think what I'll do this time is I'm going to take the 2y over to the left to get it. The y's together. And I'm also going to take the 6x to the other side to get it away from the y's. So I did 2 things at once here. Okay, so the 6x's cancel and the 2y's cancel. So on the left, I got 3xy minus 2y. And on the right, I got negative 6x minus 4. And if you wrote negative 4 minus 6x, that's okay. Ordered really doesn't matter. So again, I got these 2 y's here. So I'm going to factor it out like a GCF. So I got 3x minus 2. You don't have to worry about factoring anything on the other side. And then divide by that 3x minus 2 to finish it up. So what's my restriction gonna be? What number do I put in for X to get that, and then subtract 2 and get 0? 2, what? If you're not sure, just set it equal to 0 and see what makes it 0. So we would add 2, right? And then we would divide by 3, right? So it can be 2/3. Sometimes it's a fraction. So that's the inverse of number 4. Yours might look a little different than mine, depending on which side you put your y's on. You might have had 6x plus 4, and down here, negative 3x plus 2. Negative switches. Right, Brett? Okay, so, if yours doesn't look exactly like mine, it still could be right. I'll just check the signs to make sure. So, we understand 3 and 4 now? Those are the ones that usually give us trouble. Number 5 is real easy. All you're doing is substituting in. So we have this function, f of x is 5 to the x power. And you're supposed to evaluate it for x equals negative 3. So all you're doing is going 5 to the negative 3rd power. Which fraction is 1 over 125? Decimal is 0.008. Either one's acceptable. That's all you have to do there. That's all you have to do tomorrow. I'll give you a function. You just have to substitute in. It's an exponential function is what we call it, because the variable x is the exponent. Okay? And we'll use these exponential functions more Thursday, Friday. We're going to start talking about logarithms Thursday, Friday. And then number 6, we're just going to use the graphing calculator. Okay? So we have this function, a equals 500 e to the negative 0.018 t power. Okay, and this is a function that gives the amount of medication in milligrams in a patient's bloodstream t minutes after it has been injected. Okay, so it probably started out with 500 milligrams the shot, and then as time goes on, it kind of wears off, right? So there's less of the medication as time goes on in your bloodstream. Okay, so it says using a graphing calculator, determine how long it will take for the amount of medication in the patient's bloodstream to reach 302 milligrams. Okay, so this would be, we could, once we start going over logarithms, we could put 302 here and solve for t and figure it out. Okay, but we'll just put it in our y equals in our calculator. We'll go to our table and look for that 302. All right, so we go to our y equals and then 500. Now to get this e to a power, you hit second natural log there, just left of the 4. That gives you e to the power, that e value. That's a irrational number called the natural exponential function. But it's a number like pi. It just goes on forever. All right? And then we put our negative 0.018. We don't have a t, we'll use x and close it off. Now, some of you, when you hit that caret button, you don't have to put the parentheses because your calculator pops it up there for you. All right, you don't have to graph it. Just go to your table now. Second, graph your table. And the x column is the number of minutes. Okay, if I go back up to 0, I'll just start my table at 0. We'll go by minutes, 1 minute at a time. All right, so when we started, we had 500 milligrams in the bloodstream once we injected it, okay? And now we're gonna look in the Y column for that 302, that's what it said, right? Yeah, 302. So we just go down, looking for 302 in the right column, but our answer will be the X column, because that's the number of minutes. So it looks like 28 minutes it'll take to get us down there. So that's A. Just looking at the table. Okay. And B, the question was, find the amount of medication in the patient's bloodstream 55 minutes. So you could just hit your down arrow key and go down to 55 if you want. Or you could put 55 in for T. All right? So you can keep going down, hold your arrow down, or you can just put it in. 500, second, natural log, negative 0.018 times 55. And then close it off. All right, remember, that means times T here. You can't just put 55. Right, that won't give you the right answer. So it'd be 185.8 milligrams, is that what it was? Yeah, milligrams. So after an hour, just about an hour, there's only that much left of that medication in your bloodstream. Okay? Questions?
How do you type it in? You calculate it in?
Yeah.
All right, so you go, you do the 500, right? And then you go second ln, right next to the 4 there. That'll give you that E to the power. Okay?
I did that. I'll give you some.
All right, then it's negative 0.018, and in this problem, it was 55 minutes. You know, we figured out what, 28 minutes? Is that what we figured out? If I go times 28, it's gonna be around 302.
How do you find the 28?
I went to the
Yeah. But
I put it in there, and then I went to the table.
Yeah,
Your table messed up?
I don't know, I'm in the 400.
this is 491.08 whole way down.
All right, you actually put a number in there then. You have to put X when you do your Y equals. No, you needed an X after the 8.
Oh, okay.
Right there. Yeah. Does it give you parentheses when you do that or no? You wouldn't have to, because yours automatically pops it up there.
So I don't need a constant.
No. Any other questions, calculator wise? Your little calculator, your little non-graphing calculators would do part B because you know it's 55 minutes. Okay, it's part A that you wouldn't be able to do in a normal calculator. You could guess and check. Put numbers in it until you got the 302. All right.
It's still in charge.
There is a way to solve without the graphing calculator, but we haven't gone over logarithms. So we'll go over that stuff Thursday, Friday next week.
I don't really do it.
Yeah, mine's not with you.
Calculator error. I think it's user error.
I think that's popular.
All right, I'm gonna clear it. Yeah. Your Y equals. Any other questions?
Negative
No, they didn't have that. Graph for cable. Oh, you're looking at 302 on the X. My goodness. That would be for part B. But you're gonna get that, in your table, you're gonna get that 185.8 every time. You gotta put X in there.
No, no.
You're looking, no, you're looking for 302 on the line. X is the number of minutes.
That's taken down.
Hit enter.
I didn't put it
Now
down.
hit second graph. You go down, you see 302 in the right column. Okay. If you wanna do, you can keep going down until you get 55 minutes on the left. You know, do part B and you wanna do that. Anybody else have any questions? No.
Like this picture up.
You can take your name off, really. Shane, don't run away.
Essential, there we go.
Is that the word, Jordan?
Yes.
Shane, up.
Hold on.